is that by the end of the day, we are reminded about fraction and exponent rules, and that we can obviously simplify expressions or even solve expressions that have exponents in them and fractions. And we should also know why we cannot have a fraction of with a denominator of 0, and why anything to the exponent 0 is equal to 1. So hopefully at the end of this, you will know how to do all of these things. Okay? So first things first, simplifying fractions. So there's different operations that we can do with fractions. There's adding, subtracting, multiplying, dividing. Let's start with adding and subtracting. Okay, in order to add and subtract fractions, what do I need? Zion. Yes, so anytime I'm adding and subtracting fractions, I need to have a common denominator. Sorry, I might actually just write right on my screen here. Okay, common denominator. And then once we have that common denominator, we will keep the denominator, and then we'll add or subtract the numerators depending on what we want to do, what operation we want to do. So we actually only add or subtract the numerators. We don't add the denominators together or subtract the denominators. So once we have that, we will keep the denominator and add or subtract the numerator. Oops. Okay, so that's the deal with adding and subtracting. When we find a common denominator, of course, we always want to find the lowest common denominator, okay? We don't want to, if I'm dealing with like, I don't know, 6 and 8, our go-to might be to say, oh, 48, you just multiply them together to get that common denominator, but there's actually a lower common denominator for 6 and 8, which is 24, right? So we're always looking for the lowest common denominator, right? So that we have our fraction in reduced form. Okay, multiplying. Multiplying, I don't know if you guys are used to doing this, but when I'm multiplying, it's actually really great to first reduce anything that I can. So I can reduce actually any top with any denominator, any numerator with any denominator, as long as it's all being multiplied. And that will allow me to multiply and have my fraction in reduced form, okay? So what I'm going to do is first reduce as much as possible, and then I will multiply the numerators and multiply the denominators. And I'm going to kind of show you an example of that. Okay, so we're kind of like multiplying straight across. Multiply the tops and then multiply the bottoms. So this is what I actually want to do. I think that this is the best way to do questions where you're multiplying, because then we don't have to reduce at the end. So a really good example could be something maybe like this. Or let's just say this. We'll just do that. Okay, this is a simple example. All right, so If we look at the individual fractions, there's actually not really much that we can reduce here. The 2 and the 3, I can't reduce those. 9 and 8, I can't reduce those. If I could, then I would, of course. But I can actually cross-reduce these guys. So anytime I'm multiplying two fractions together, I can actually do, I can simplify any top with any denominator. So out of 2 and 8, I can actually reduce that to 1/4. Okay, and then 3 and 9, I can divide 3 into both of those, right? So I can actually reduce that to 3 and 1. And then because I have a y on top and a y on the bottom, I can also cancel out those y's. So any top can be reduced with any bottom part when I'm multiplying. So actually all I have left here is 3x and 4 underneath. And see how that nicely, it's all nicely reduced already for me if I do that kind of cross-canceling. Okay, we can only do this when we're multiplying though. Okay, so my suggestion would be simplify and then multiply across. I'm multiplying 1x times 3 and 1 times 4. Okay, when I'm dividing two fractions, I will take the second fraction and then I will flip it and I will change to multiplication and then I will follow the steps for multiplication. So flip the second fraction, or the bottom one, depending on how it's arranged. Okay, and then we'll do exactly kind of like what we did up here once we have an expression where we have it being multiplied instead of like a fraction divided by another fraction. Okay, when I flip the second fraction, I only just like swap the numerator and denominator. I don't have to do anything else. No signs change or anything like that. So we're literally just taking it and flipping it upside down. Okay, so this is kind of this rule that I'm talking about here. So we can only cross-cancel when we're multiplying. However, at any time I can reduce just like an individual fraction if I need to. Okay, so if I have something like 2/4 plus 1/2, I can't cross-cancel any of that, but I can always reduce an individual fraction. Okay. So we can always reduce an individual fraction, like what we have as 2/4 here. So if you ever need to, you can. In this case, it's actually easier for us to just reduce it, and then I can actually just add those together, right? But this like little cross-canceling thing that I did when I showed you this multiplication, I only want to do that if there's a multiplication sign between. I can never do it if there's any other sign. Okay, so far so good? So those are just some reminders for us. I feel like we make fractions this big thing. If you just kind of know the general rules and you practice them, you'll get good at it. So it's just about practice, and it's just about making sure that we're just careful when we reduce and things like that. But don't freak out about it. If you make it bigger than it is, then it becomes a whole thing, right? But if you're kind of like, I can do this, positive self-talk, then you can do it. Okay, am I good to scroll all the way down to the next slide here? Elise, you good? Okay. Okay. We can never have a fraction with a denominator of 0. Okay, so why can't I have 6 divided by 0? Ivana?
It's not a real number after.
Why not, though? Okay, well, if I ask you guys what 6 divided by 2 is, we all know the answer to this. It's equal to 3, right? And that's because 3 times 2 equals 6, right? So I can actually kind of check this by saying this times this should equal my numerator of the initial division, right? Well, if I'm asking myself this question, what times 0 equals 6? Well, what times 0 equals 6? Nothing. And that's why dividing by 0 doesn't really make sense, right? Because when I divide by 2, I'm saying I'm splitting 6 up into 2 groups of 3, right? But when I divide 6 by 0, I'm splitting 6 up into 0 groups. That doesn't really make sense, right? So when we think about like division and multiplication, we want to think about like groups of, right? So 6 into 0 groups, that just doesn't compute, right? Doesn't make sense. So this is not possible. We can't divide by 0, right? Okay, and then just so we're all clear, when I'm doing this reducing up here, I am not cross-multiplying. I'm cross-canceling. Cross-multiplying is only done when you have a fraction equals a fraction, and we're not going to be actually even using it, so I'm not even going to show you an example of it, just to kind of keep us away from using that. But it only happens when you have fraction equal to a fraction, and we're not really going to be using that, like I said. And I think I'm frozen here. See if that helps. Oh, there we go. Okay. So we only use it if we have fraction equals a fraction. And then we multiply the denominator up on both sides. So we're not really going to have to worry about cross multiplication, okay? We are going to cross cancel, like cross reduce like I showed you, but not cross multiply. Okay, so that's kind of the foundation. I also want to quickly review exponent rules with you guys. And if we have a good foundation in these, it's going to make some of our other work that we're going to build on tomorrow a lot easier. Maureen? No? Okay. All right. So we're first just going to go over the exponent rules quickly, and then we'll go and do the examples on the right-hand side of this chart. Okay, so product rule. Does anyone remember product rule? What happens when I'm multiplying? Ivana?
It would be addition, so A plus B.
Right. So we will keep the base. Oh, I think I'm frozen again. We're going to keep the base. Yep, there we go. And add the exponents. So the x stays, and then we do the addition of the two exponents. A plus B. Okay, power of a power. Not minus, no. Yep. Okay, so keep the base and then multiply the exponents. We'll use a dot for multiply. Okay, Luca, quotient rule? Yes. Okay, so keep the base, and then we will do the top minus the bottom one. Okay, and then the last one is the negative exponent rule. So usually in math, Just like how we simplify radicals and how we like simplify fractions and things like that, we have some proper ways that we like to express our answers. And one of those ways is having no negative exponents left in our final answer. So the negative exponent rule just helps us get rid of negative exponents. And what it says is that wherever I have a negative exponent, whether it's in the numerator or the denominator, I switch it to the opposite side of the fraction. So if it's in the denominator, I'll move it to the numerator. If it's in the numerator, like this one is already in a numerator, I will move it down into a denominator, and then I can make it positive. So when I move this guy down into a denominator, I just have a 1 left on top. And then I can make the exponent positive. So you're just going to switch it to the opposite side of the fraction and make it positive. Okay, and then one little thing that I want you to add to the bottom of this, or you can add it right at the top if you want, is the exponent of zero rule. Okay, so for instance, if I have anything to the exponent 0, does anybody know what this is equal to? 1, not 0. Okay, the question would be, why? Why is this equal to 1? Well, there's one way that we can prove this that will kind of help us understand why this is true. So I can actually use the quotient rule to help me prove this. So x to the exponent a over x to the exponent a. On one side, I can keep the base and subtract the exponents, right? A minus a, and then I'll get x to the 0, right? So I know that x to the a over x to the a is x to the 0. Agreed? Okay. On the other hand, I also know that anything divided by itself is equal to what? 2 divided by 2, 3 divided by 3, 1. So x to the a over x to the a I know is actually equal to 1. So therefore 1 must be equal to x to the exponent 0. Okay, that's a really simple proof that we can just show why this is equal. Okay, and then of course we also know that only things that can be, that are the same exponent value and base can be added or subtracted together, right? So I can't add like an x squared and an x, or an xy and an x squared y, right? Things like that. They need to have the exact same exponents and bases. Okay, so we'll do these examples on the right-hand side here. So this guy, we will keep, I hope everybody knows these laws already, but we're just going to keep the last name part of this and subtract the coefficients. So here we'll get negative x squared y. Just doing the exponents on the right-hand side of the chart there. Okay, everyone good with that? Okay, same idea here. So keep the w, keep the last name part, and subtract these guys. We get 2w. Okay, that should be, like, everybody should have this down. I shouldn't even have to really say that. Do these two. Okay, next one, h squared. Sorry, you guys have a 6 here, so I'll change mine to 6. H squared times h to the exponent 6. We will keep the base and add the exponents to give us h to the 8. Sorry, maybe I need to write a little bit bigger so everyone can see. H squared plus h to the 6. Not that much bigger, but here we go. Okay, multiply coefficients. We're just going to kind of work our way down here. Multiply a's. So keep the base, add the exponents. So we'll get to plus 3. and then do the b's separately. So b and b means I want to do 1 plus 1 here, and then we'll just simplify. If you can do this in one step, that's totally fine. I don't need to see all of it. Okay, so we'll get a to the 5 and b squared times negative 14. Questions so far? We're good? Okay. Power rule, I'm going to keep the base and multiply these guys to give me x to the exponent 6. Thank you. All right, this guy, remember your bedmass rules. We want to do exponents first, and then we can do any multiplications that we want to do. Also, I want you to remember that this squared applies to both of these things in here, not just the m to the exponent 5. So I need to do negative 2 squared and also m to the exponent 5 squared, which gives me positive 4 m to the 10, 2 times 5. And then I want to multiply it by m cubed. So I will keep the base and add the exponents to give me 13. Okay, so that is a mistake that I see a lot. People forget to also square the coefficient. Any questions on this one? Okay. I'm good to scroll. Okay, quotient rule. So we can just reduce this fraction. What's the biggest thing that goes into 27 and also 42? Anything? Can we reduce?
9.
Final answer?
It's 9 over 14.
Yeah, so 3 goes into both of them, right? So I'm going to reduce 27 by 3 and also 42 by 3 to give me 14. And then what happens here, guys, is we actually keep the base always on the top, and we'll do top minus bottom. So if I end up getting a negative, I'll move it into the denominator after and make it positive. Otherwise, it's assumed that that value is going to go into the numerator, okay? So put it in the numerator, and then if you happen to get a negative from that, you can slide it down to the denominator and make it positive. Okay, this guy, I'm going to do power rule first. So doing exponents first, I get y to the 4 over y to the 4. There's actually 2 ways that we can solve this one. I know that anything divided by itself is just 1. Or if you want to kind of like prove it, we can do y and then to the 4 minus 4. That gives me y to the 0, which gives me 1. You can go right to this if you want. Any questions on these two? Okay, negative exponent rule. This right here is an exam question, and the pass-fail rate for this question is about 50%. So 50% of people by the time the exam comes know how to do this question, even though every year I tell people at this point right now that this is an exam question. Okay, not exactly, but I can change the numbers and it will be exactly the same anyways. So does this negative 2 apply to the x or the negative 5 and the x? No. It just applies to the x. So what I want to do, this 5 has an exponent 1. Okay? There's a very big difference between negative 5 to the times x in brackets to the exponent negative 2 and what we have, right? An exponent only applies to what's directly in front of it. So this negative 5 actually has an imaginary exponent of 1 on it. So when I'm using the negative exponent rule, I actually only want to take the base of the negative exponent and obviously the exponent itself. So the negative 5 is actually going to remain in the numerator here, and I will move the x down and make its exponent positive. Okay, because the negative 5 has a positive exponent of 1. So that one stays where it's at. Okay, and this is actually what I was talking about in question number 7. So here I can actually reduce that to 1 over 2, and then I have k 3 minus 5, and I'm actually going to get negative 2 here. So what happens here is I actually want to move that now down into the denominator, and there's a 1 left over in the numerator, so it'll be 2k squared. Okay, just so you guys kind of like can see a little bit, I usually just do kind of like a balancing thing when I'm dividing. So if I have 3 k's on top and 5 k's on bottom, and I cancel out 3 from each, I'm going to be left, 3 and 5. If I cancel out 3 from each, I'm going to be left with 2 on the bottom, right? So it should make sense that I end up with k squared on the bottom. Okay? Usually I don't even go through this process at this point. I just kind of balance these guys out. Cancel 3 out from each, I'm left with 2 on the bottom. Okay? I like to kind of think about it that way. Cool? Any questions for those guys? Hi, what's up? I don't have it on me, but I can post it for you if you send me a reminder message. All right, so we're going to do just a little bit of fraction practice here. The very first thing that I would always do if I'm adding and subtracting fractions is just see if I can first reduce, and it will make my life so much easier. Okay? So I can only reduce in the individual fractions because I'm adding and subtracting here. So I can actually, and again, I'm going to kind of just do that balancing thing. So if I have x cubed and x squared, and I cancel out 2 from each, how many x's am I left with, and where will they be? 1 on the top, right? So this guy can just reduce to 3x over 2. Okay, canceling out 2 x's from each of these, I'm left with x to the 1. And over here, I have 4 y's on top and 1 y on bottom, and I cancel 1 out from each, so I'm left with 3 y's on top. Okay, so as much as you can, we want to reduce the fractions, the individual fractions, and then we can go ahead and find a common denominator. So 2 and 3. I think my common denominator is pretty simple. We're just going to multiply by 2 and then multiply by 3 on the left here so that we have a common denominator of 6. And then we're just going to put them together in one fraction. So final step to simplify is merging these guys. Is there anything more I can do? No? Do you guys agree? What about this 8 and 6? Can I cancel? Think back to what we talked about with quadratic formula, right? When I'm adding terms on the top, I don't want to individually cancel those terms, right? So if I can't common factor anything from the top, then I can't really go any further with this. Okay, now if you forgot to reduce your fractions at the beginning, you will have to common factor and reduce at the end. Okay, so this will save you a lot of work if you remember to just reduce first and then go ahead and find your common denominator. If you don't, you're going to have to do some more reducing once you get to the final answer. Okay, so that would be final. All right, over here on the left, I'm going to just reduce here. So I have 1 y on top and 2 y's on bottom. I want to cancel out 1 from each, so I'm left with 1 on the bottom. So I'm just going to be left with a y there. I can't do anything with the fraction on the right. Okay, I have a 5y and I have a 4x squared. So we need a common denominator between the 5 and the 4. and also between the variable part here, right? So my common denominator between 5 and 4 is 20, okay? But also the right-hand side needs a y on top and bottom, and the left-hand side needs an x squared on top and bottom as well. So what I'm going to have to do here is multiply the top and bottom by 5y on the right-hand side, and this guy I want to multiply by 4x squared, so that my full common denominator is 20x squared y. Okay, and then I'm just going to merge these guys into one fraction here. Sorry. There we go. That looks better. Okay, I would always do just a final check to see in the numerator, like when you're adding terms or subtracting terms like this, check again and see if there is possibly a common factor in your numerator here. If not, then you're finished. Okay, so out of 8x squared and 15y squared, there's not really anything I can take out from that. Remember that I also can't cancel individual terms, so because there's no common factor, I know that I have done everything I can do. Okay? Again, this like initial reducing is key. It will make your life a lot easier. Okay, one other little note in your worksheet from today, you will see the square root of some numbers. So if you have the square root of something like, I don't know, let's say you have 9 over 24, something like that. Or actually, let's not do 24. Let's do something that 9 doesn't go into. Let's say 32. Just like when I do like the multiple of two things under a root, I can split them into their own roots. It's the same with division. So I can actually split these guys into their own roots, like so. And then I can actually just simplify the radicals that I have here. So you will have to do this in your worksheet. And then I would split 32 up into 16 and 2. And then we would write it as this. Okay? So the square root of divisions can be written as the square roots of those individual divisors, the numerator and the denominator. Okay, so you'll see that in your homework worksheet or something like it. Any questions? Okay, so you guys have a great opportunity to take about 40 minutes today and really get a good handle on this. If you feel like you know this stuff already, that's awesome. I still want you to do it because we need to get back into the practice of knowing how to use these exponent rules well and quickly, and also fraction rules, okay? So even if you feel like you know how to do it, I want you to just do some really good practice. It will put you in a good position moving forward, okay? All right.